So, hi everybody, I'm Michael. This is a talk on multi-party block construction, or building towards multi-party block construction. Much foreshadowed, I hope we managed to debug kind of the technical side of things. Yes, this seems to be working. We are a bit short on time, and multi-party block construction is a big topic, but I think that the solution we are proposing here is quite intuitive at its core, and for that reason I think we can make it through within the allotted time of 10 minutes. To give some background, I'll start with the who. So the Blockspace Forum is basically a group of various industry participants, many of which I see in the room, such as Ultrasound and Gattaca and ASTUS, coming together to address some problems that we see with the current transaction journey. Now for disclosure, I'm a research advisor to Gattaca, which is the firm behind Titan, and work with some other teams too, such as the Blockspace Forum itself. We have a website, there's a QR code here. If you scan that, you'll see our articles, you'll be linked to our Twitter page, and there's also a little bit of a introduction to the out-of-block construction pipeline for those that would like to catch up on that. The why multi-party block construction? Well, earlier I mentioned that there are certain structural gaps in the transaction pipeline. These gaps fall into 4 categories of economics, robustness, performance, and services. The Blockspace Forum had 2 installments now. After the Buenos Aires installment, some people came together and formalized these gaps a little bit more. So if you follow the QR code, you'll land on an ETH research post, which very clearly walks through these dimensions and then gives some elaboration on what we believe can be improved in terms of block construction. Now, I mentioned that Buenos Aires, and this post corresponds to the first installment of the Blockspace Forum. There was also a second installment not so long ago in Cannes. And then following the Cannes installment, we started to work from the problems towards solutions. This post, myself and some others published it around 2 weeks ago, and it's basically a pragmatic first design of what multi-party block construction could look like. Now, the post is called Building Towards for a reason, and the reason is that it's a complex topic, and therefore we are looking at a process which is, longer term, right? It's very dynamic. We want to be pragmatic and incremental, right? Sometimes move fast and break things. Here, we definitely don't want to break things. And for that reason, we will start with pragmatic solutions and then extend these in terms of scope. What is multi-party block construction? Well, I think really it has to be boiled down to one sentence, which is it allows multiple builders to contribute to a single block. And if I actually add to that, and what does this mean? Well, it means that it leads to multi-party blocks which have higher block space utilization and higher block value than single-party blocks, right? Because you have whatever one builder can accomplish, and then you just additively extend onto this. The current PBS pipeline, so given where we are this afternoon, I don't think I'll have to talk too much about it, but I just want to highlight some structural features of this, which can be gleaned from the diagram. It's basically a connection, or it searches for a connection between the single builder that has submitted the highest bid block with the proposer. If you look at the graph, this is the green line here, which runs at the very top of the screen. And then you have various downstream effects. So if you want to look at it from a really fundamental level, it's basically only transactions that are available to the winning builder are included in the block. And actually, you can potentially extend this even a bit and say only transactions available or selected for inclusion by the winning builder are included in the final block. Okay, so if the builder either willfully excludes something or doesn't know about the transaction, there's no way of landing. Multi-party block construction is really simple fundamentally, because what you do is we basically connect multiple builders to the proposer. The way this works is builders still submit their blocks via a service provider such as a relay. We call them operators here, and then operators look at transactions within the different blocks that they have received that could be tagged onto the single best base block in order to strictly increase block space utilization and value. Now, naturally, this means that the scope at the moment is limited to transactions which don't compete for contentious state. They are appended to the bottom of the block, and the execution guarantees of the winning builder cannot be affected. Why operators here? Well, I mean, we heard earlier today that relays naturally fulfill many important tasks that increase block value. Escrow, however, is not something that is envisioned under ePBS, and operators, the operations they provide, are only relevant when they increase block value, right? Therefore, this is not an instance that's always there. The operator is there whenever it can increase block value. Okay, so we connect multiple builders to the proposer. Transactions can be included from multiple channels, and then it's strictly additive, right? So in expectation, you're greater than or equal to 0 versus what a single builder block could accomplish. The impact of multi-party block construction. Again, I think like very nice property here is that it's really easy to wrap your head around what the impacts are. If you look at the dimensions here, so who contributes to blocks? Well, at the moment it's one winning builder here, it's one base builder plus multiple contributing builders. What are the transactions eligible for inclusion? Again, we don't learn, currently it's transactions known to the winning builder. Here it's transactions known to the base builder or contributing builders, okay? Same therefore holds for inclusion paths, and then there's various downstream effects, some of which will be discussed further on the next slide, but let me just mention a couple here because we talked about 4 dimensions of structural challenges before. Services such as proposer pre-confirmations currently require opt-in by the winning builder, otherwise you can't take the block of that builder which would have access to the most valuable block. Therefore, you run a huge opportunity cost from offering services if they are not commonly accepted. Okay, here this gets a little bit easier because even if the winning builder or the builder with the most valuable block does not support that service protocol, the transaction can still find its way into the block. Nice consequence for censorship resistance, then of course transactions that the winning builder does not want to include, they can also find inclusion via these channels. Performance and UX. They are really, at the moment, if any transactions that the winning builder doesn't put in, they end up in the next slot, which means that originators in that subsequent slot compete with these transactions for inclusion. This is really an inefficiency which we want to offset, right? And here, because we have higher block place utilization and because we have multiple channels, we have more predictable inclusion, the need for defensive overbidding is reduced, right? So in summary, higher block space inclusion plus more predictability because of less discretion means you don't need to overbid so much for inclusion. Those are the impacts. Let's look a little bit at the consequences. So this is a whole laundry list of things. Therefore, I'm not going to read them out, but I'll highlight some of the more fundamental aspects here. On economics, at the moment, the price discovery for a block or transaction is limited to a single builder's views, and once you can feature transactions from multiple builders, this extends to the view of multiple builders then naturally. For robustness, well, at the moment, you kind of have a concentrated builder and relay set. There's winner-take-all dynamics. You win the slot or you don't win the slot. It's really binary. Well, here you can not win the slot, but you can still add transactions to it, and then you get compensated for that, right? Therefore, we expect that it can improve robustness, A, by reducing barriers to entry, and B, by having these separate paths which can improve censorship resistance, which is what I mentioned on the last slide. Transaction spillover is reduced, and then service support, I'm not going to repeat it, but basically if you have 5 builders that could support the service protocol such that transactions issued by the protocol can be in the block, it's naturally better than if you have only one builder that can support that protocol. The implementation, yeah, so I don't want to dwell on it too much. If you are interested in this aspect of it, the post is the best place to consult. But in summary, there's 5 really simple steps, of which I think the last one is very important and important to highlight. So A, operators identify the highest bid eligible single party block. Then they add constraints to it if they're missing, such as proposer commitments. Then they add mergeable transactions to it. And then lastly, that additional surplus needs to be distributed. Therefore, they add value distribution transactions. And then that last step is you basically compare this multi-party block that was just built with the best single party block that came over the wire at the end of the slot, and you give whatever is most valuable to the proposer. And this is where the condition comes from, that the multi-party block has a value that's greater than or equal to what the proposer could get elsewhere. It's encoded in the check. There's also other auxiliary improvements which we think this system can naturally support. Operators can share information, and when can operators share information without giving up a competitive edge? It's when they reduce variance, right? So for variance of block propagation or compliance variance with something like proposer commitment support. If you can work together to reduce variance, this is something that kind of increases the size of the pie, right? Therefore, it can be very positive for operators to do this in some instances, okay? Some things that operators can share, we heard it before, builder emotions. If several operators share information on builder emotions, they can enforce a consistent view. Therefore, builders don't need to post so much collateral, and barriers to entry for builders fall, right? Yeah, so it's a really simple underlying mechanism, but there are many of these kinds of consequences. Again, if you're interested, please do consult the post. Maybe one other thing I want to highlight here is operators can work together to propagate payloads, right? Send transactions to attesters. And this kind of additional geographic network coverage naturally benefits more distant proposers in expectation. Next steps, well, so this design is building towards design. It's an incremental design. So there's some gaps. Value distribution is the next gap to be addressed. There's a surplus. How does the surplus get distributed? It should be distributed in a way that benefits the proposer, builders, and operators over what they can currently earn. Operators are trusted. This mirrors the way that the block auction is conducted currently. However, we can imagine some ways that we could do better, and this is another remaining question. Transaction coverage at the moment, this is limited to transactions that can be appended, but you could extend it to transactions which compete for contentious state. This, however, then is quite complex because you need to simulate dependencies. So this is for later too. Yeah, in summary, this system, multi-party block construction, will be live on mainnet in the next months, and then we expect it to improve continuously from there. Community feedback is actively encouraged. When I showed the Blockspace forum slide earlier, you saw a couple of logos on there, so really anybody that wants to chime in is more than welcome. And then lastly, the Blockspace forum will return quite soon, later this year. Thank you. Yes, Christian.
Not about how this interacts with eVPS. I assume that from the protocol perspective, the operator will then become the builder, right? Because he's the only one they're the only one that has the full payload even to be published, and they will also have to sign and potentially manage on-chain, like unless they have collateral to pay trustless bids and that stuff.
Yes, so I think this interacts with ePBS in a few ways. Some are conceptual, others are more technical, I think, on the conceptual side, because escrow is not needed anymore. We expect operators to not be there for strictly every slot, but only when they can improve value. In terms of whether they would have to be staked in protocol, yeah, I mean, if this is a requirement that the operator has to re-simulate the block after it added transactions, then this is something which I think would be fair to expect, yes.
Do you expect order flow agreements to fit into this?
So the way this works is the builder makes blocks eligible for multi-party block construction and specific transactions eligible, and therefore the builder would be trusted to manage the relationship with order flow providers, right? So they might want to enroll certain types of transactions which have more dynamic or no rebate agreements, and for other types of transactions, maybe it would be a longer-term process for them to get them opted in. If you're an originator, there's advantages here, for example, such as faster inclusion, right? So it's kind of like a trade-off.